All right, so in this video, we're going to take a look at the merge sort function. I'm going to use Java to kind of explain an example here, but this could be really applied to any language. So let's dig in here. Let's take a look. So the merge sort, when you break it down, is two different it's basically two different things going on. The first thing that's going on is we are dividing the array or list of whatever data structure you're using. I'm going to show you an example with an array. So we divide it or break it down. And in this step, we divide the array into two halves, and we keep finding the midpoint and divide the array, find the midpoint, divide the array until we get down to size 1, and then we start to build it back up. And so that array that was built back up, we now that was broken down, we now build back up. And as we do that, we sort it and merge it together. Okay. So this is a nice visualization of what that would look like. You get to you have your array here, and we find a midpoint. We break it up, find a midpoint of each of them and break them up until we get to size 1. When you have an array of size 1, technically that is already sorted. So now we start to put them together. And as we put them together, now we're going to put them in the correct order. So you see how we shift the 6 and the 10 here, the 5 and the 8, and so on. And what that code looks like for your merge sort code is you send it an array. My list was the name of the array. That's why I call it ML. And the low, which would be 0, and the high, which would be the name of your array. So ML.length -1. And then we come on in here, and we, as long as the low is less than the high, which means your array is has more than one element in it, we're going to keep finding the middle point, and then we're going to kind of break the array up according along the lines of that midpoint. So we're going to create a left side, which goes from the low to the middle, and then the right side, which is the middle +1 to the high. And we just keep on doing that. And then lastly, the last call here, after all that recursion is done, then this merge gets called. The merge is technically not a recursive call. But it will get called a bunch of times because of all the times this merge sort keeps getting called into here. In our example that we have right here, this would technically be called as many times as we have arrays down here. So 1, 2, 3, 4, 5, 6, 7, and then the merge array would be called to start putting this back together. And I'll show you real quick what that looks like code-wise. We send it the original array, as you see here, and then we create this helper array, and we add all the elements from our original array into the helper array. And then we create some variables that are going to help us kind of put it back together. So the low variable, you can think of that as spot 0 for the array that's like the left side array. If we were looking, let's say if we were looking right here. So let's say we have this array that has 6 and 10 in it, and an array that has 5 and 8 in it, right? And so the low would represent the first spot in the in that 6 and 10 array, okay? And then the J, which is middle +1, is actually going to represent the spot 0, the first spot in this 5, 8 array here. And so then what you do is you go and you see, all right, so is that first spot in the array that was to the left-hand side, is that less than our helper value? and basically J here, if you look at that. So is that greater than the one to the right? So basically that's comparing this 6 and the 5. So the answer was no, because 6 is greater than the 5. So if we were kind of looking at this, it would go to the else, and then we would we would actually add the J1, which represents the array to the right, to our main array, which is called my list with the K value that's starting at spot 0, right? And so basically my list will be starting from scratch. You'll be giving it all the values, but in order now. And then we increment that J, and we increment the K, so now the K is looking at spot 1 instead of spot 0, and the next smallest value will be saved to our list. And so if we ran through that again, we look here, and we would examine the 8 to the 6, and this time the 6 is smaller, and so that would get saved here, and then we'd increment the I, and this would keep on going until we were done, and we had the whole anything that was left over. This is what's showing here. Anything that's actually left over would just get added to the array. And by leftover, what I mean is, so after the 5 and then the 6, then the 8 gets added, the leftovers to 10, and that would get added, and now we have this. And then the next time called through, we would examine these two, and the same thing would happen for merging them back together. Hopefully that makes sense to you. It's a good array. The recursion makes it a little more elegant. It makes it fast. It's n log n, which is a pretty fast array. As you saw, the merge portion of the array was not recursive because technically it's not a method that's calling itself, but the merge sort part is, because that is calling itself. Let me know if you have any questions, but this is that's merge sort in a nutshell. I have this code here that I'll share with you, and just so you kind of see, this is what the original call looks like. Name of your array, then 0, and then length -1. In my code here, I'm making a bunch of random numbers. I show them to the screen. Then we call the merge sort. Then I show them to the screen again, just so you can see that it's working. And I'll run that for you so you can see. There you go. So the top one was the scrambled up array, and this is sorted using the merge sort. Thanks. I hope that was helpful.